Hello everyone, this is Joseph Porter, your host, and you're listening to The Next Layer. In this podcast, we're looking to explore the world of additive manufacturing, from hobbyist applications to complex engineering solutions. Our focus is to not only learn about the current state of the market, but where it is going and how individuals like you and I can take part in these trends. We'll be interviewing hobbyists, engineers, and scientists, discussing new techniques, applications, technology, and discovering what the future of additive manufacturing will entail. Whether you're an aspiring creator or a senior research scientist, we hope that you listening are able to learn something new. We'd like to thank our sponsor, MarketList.com, for making this episode possible. MarketList is an online contract bidding platform for additive manufacturing where local manufacturers have access to a wider range of work that they can bid on, and clients can receive offers that best fit the needs of their project. If you're interested in saving time and money on your next 3D printing project or taking on more clients for your business, stop by MarketList.com. The link is in the show notes. In this episode, we have Rich Boling on from Techshot to talk about 3D printing in space. In our discussion, we talk about the late great Chuck Yeager, what it's like to work and talk with astronauts in space, 3D bioprinting, and their newest fabrication lab. They'll be making tools to further space exploration. Thank you to those listening, and we hope you enjoy this episode. So I've got Rich Boling on the line from Techshot. So Rich, tell us a little bit about yourself.
Well, I've been at Techshot for 20 years now. I actually came not from the space industry, but from a large PR firm. And I had great clients like UPS Airlines, worked with the great Chuck Yeager that we just lost recently on projects. And the airport in Louisville was a client, and I never thought I'd leave them, but I'd always had a personal interest in space flight. And when an opportunity came up in my hometown or in the town where I was living to work in a company in space, I just called him up and said, "Stop looking, I'm the guy." I thought there's no time for modesty whenever your dream job comes up, and that was 20 years ago, and I've had just a heck of a time ever since then. Started doing PR, but really morphed into more of a management role, doing now, besides some public affairs work, a lot of government affairs work, and business development.
That's fantastic. So that's a very bold way of grabbing a job, but that's super cool that you did that. What was that like with that conversation with the person when you were going to ask for that?
Yeah, I think it probably was not a common way to do an interview or to set up an interview, but and maybe I guess you could debate the merits of how smart I was. I mean, I got the job and I'm still there, but it really was a job. Short of being an astronaut, I mean, when you're a kid, the jobs you know about in the world are what your parents do: cowboy, race car driver, policeman, fireman, and astronaut. And I really wanted to be an astronaut early on when I was even in junior high school. But at the time, really, astronauts were mostly fighter pilots, or they had been, or test pilots, and I just didn't have the vision that would allow me to do that. And so I sort of took on other interests, and which included a lot of things related to storytelling and being able and communication, which I'm fascinated by. And so I guess I thought this was the next best thing, and I wasn't going to lose my shot.
That's awesome. And I think you mentioned that you worked with Chuck Yeager. How was working with him, and what did you work with him on?
So I first worked with him on a volunteer basis. I was the volunteer head of public relations for a big air show that was in Clark County, Indiana. And I'd been a big fan of the movie The Right Stuff. Mm-hmm. And so he was a childhood hero of mine. I mean, that's sort of the poster I had on my wall was Chuck Yeager with his P-51 Mustang. Mm-hmm. And so I got the chance to work with him. He came in for the air show, and as did many of his fellow fighter pilots from his 357th Fighter Squadron. And I was pretty nervous, but it was great to work with him. He's such a legend. And then about a year later, maybe it's close to 2 years later, we were working on a campaign for UPS related to how UPS was going to have their entire aircraft fleet, which at the time and this was again 20 some odd years ago, at the time was the world's 9th largest airline. I'm sure it's even bigger than that now, much bigger than that now, perhaps. And so all airlines had to meet a certain standard for quiet operation. And the UPS decided to spend, nearly $1 billion re-engineering aircraft to make them really, really quiet, way ahead of the government mandated deadline. So we came up with a campaign called UPS Breaks the Next Sound Barrier.
Oh,
and we thought, wouldn't it be a hoot if we hired Chuck Yeager to kind of represent us and be a part of a video and go around and do community visits around the country where UPS has hubs. And we even rented out the National Air and Space Museum to do a special presentation. Commendation from the White House was going to be given to the head of UPS. Yeager was going to be the MC. So because I had worked with him on an air show before, they said, Rich, you're the guy. You're going to call him up and you're going to ask him to see if he wants to do this. And he doesn't suffer fools lightly, and is a very direct and matter-of-fact person. And so I sort of took a deep breath and called him up at the number that I had for him. He answered his own phone and just said, Yeager. So all right, really quick, General, this is what we want to do. The call lasted about 20 seconds, and he said, I'm in. And that was it. And then a good friend of mine, Laura Geedig, wrote a script. We went out to a UPS air hub, and General Yeager came in, and we shot this video about how great it was and how great it was for the environment that UPS did this. And he just sort of walked around and did Chuck Yeager. I mean, he wasn't putting on an act, but he was in real life what you would imagine he would be, which was great. And unfortunately, in Yeager fashion, true Yeager fashion, right before we did the event at the National Air and Space Museum, he was on a ladder cutting some limbs at his ranch with a chainsaw and fell and broke some ribs.
Whoa!
Like this time he's 74 years old, not 24. When he broke the sound barrier, he had broken ribs then too. So unfortunately, he couldn't do the event in DC, but it was still one of the highlights of my career is to work one-on-one with General Yeager, and he was one of the greatest generation. So a great loss.
Yeah, very much a great loss. I saw that recently, and it's you always see all these interviews and read all these articles about heroes like that of the past,
right?
Especially of just having the right stuff, especially coming out of the greatest generation with World War II, and it's always interesting to hear first person accounts of these people and like were they truly that way, or is it mostly just overall United States commercial hype, but it really does sound like that he was the real deal, which is just super cool to hear. It's nice to have those
anybody that met General Yeager got the real General Yeager. I can attest to that.
So over at Techshot, what is it that you all are working on?
So the company has been dedicated since its founding a little over 30 years ago to designing, building, owning, commercially operating research and manufacturing devices for space flight. So we first started building these research payloads for the shuttle, and we flew several on the space shuttle and a few on uncrewed parabolic flight aircraft, or not aircraft. Well, yeah, I'm conflating two things. One, parabolic flight aircraft, the Vomit Comet. So we've flown a few of those, and I got to fly on one last November, which was also a highlight of my life. But then we've also flown some on these uncrewed suborbital rockets just to test out how things might work before putting something on board, something like a space station where it'll be for months, if not years. So we've built and designed and operated these devices. Really, it's a niche of a niche that most people don't even know exists. I mean, we've had a space station continually staffed by one American or another, nonstop, for more than 20 years. And too many people believe that NASA consisted really only of 3 space shuttles, when that couldn't be further from the truth, right? And we make an entire living with 50 employees in 2 locations by building, owning, commercially operating these things aboard the station. And we do it all from here, right? So we're headquartered in Floyd County, Indiana, in a rural area of the second smallest county in Indiana. And then we also have a part of the pun satellite office in Florida at the Kennedy Space Center, where we have with interns close to 10 people down there. And I was driving past this business every day going into that office at the PR firm in Louisville. And so to work at a company that actually puts things aboard the station and talks to astronauts on board the station from their office, it's just an amazing dream come true. And it's the type of place that provides those high skill, high wage jobs that every community wants to have.
That's awesome. So I guess what's it like talking to astronauts while they're up at the space station?
We talked about General Yeager and sort of what kind of a guy he is, and I've just had the pleasure of working with, at this point, 20 years in, a lot of astronauts, and they're really smart people. For one thing, I mean, the days of being a fighter pilot, as a requirement, are not. I mean, that's still important, and many of them still are or have been test pilots, but many of them are doctors. In fact, if I had to advise someone today on a path to becoming an astronaut, I think being a medical doctor is a great way to do that. Many of them are scientists and experts in a field, and they're just really, really, really bright people. Some of the most emotionally intelligent people that I've met, and all of them to a person that I can attest to, that I've met, really appreciate where they find themselves. They've all worked hard to get there, but I think they're all very, very grateful for where they've found themselves. They're like me. Most of them are like me. They've always wanted to do this, and they've done the things they've needed to do to try to realize this dream. So they're grateful. But it's a trip to walk by in the hallway here at Techshot, and some of our staff are working from what we call our payload operations control center, where we talk to the crew, we see what they're doing in real time video with our equipment, and we control our own equipment from here in our office too. And I can't say that I ever get totally blasé about walking past what we call the POC and see our logo float by on board the station, and watch our men and women talk to those crew members. It's still a thrill every time. It's still a thrill.
So that's got to just absolutely inspire a sense of purpose as well for what you're working on, every day. And just, as you get up every day for work, just realizing what you're doing and how it's impacting the people and impacting this world. That's got to be an absolutely wonderful feeling.
It really is a wonderful feeling to sort of be able to find your bliss, and I think all the fellow employees of Techshot feel the same way. They're also very, very bright people, and they could apply their capabilities anywhere. They'd be valued anywhere, and the fact that they choose to continue to do it at our little facility in Greenville is a testament to how it's not a gig, it's a passion. It's a passion. And myself, I'm just grateful. There's a role for everyone in space, in the commercial space industry today, or just let's say in space, whether you're working for NASA or for a company like Techshot or a company like SpaceX or Blue Origin. There's a role for accountants and PR people, besides engineers and scientists. It's just this is the golden age of spaceflight as far as I'm concerned, and the doors are open, and the industry is growing.
That's awesome, yeah. And I hope people who are listening are taking away some beautiful wisdom from Rich here about how to get into this world of space. And it's not just, as you mentioned, the world of SpaceX and these massive companies that you see every day, but it's made up of all these smaller and very exciting small contracting firms, that do a lot of the major engineering work and the details that conglomerate their way up into these massive engineering projects that go into space. You can find extremely exciting roles within these smaller groups, and I would argue to say almost more proactive roles, and roles that will have almost more interesting details involved.
I think you're right. I think it would be great to work for some of those larger primes names that we all know. Um, and there certainly are roles in those organizations that have a really direct connection to big projects and big programs. But I think there are also um, a lot of responsibilities or job positions within those larger companies that maybe you're a few layers removed, or maybe many layers removed um, from affecting. So talking to an astronaut, for example, on board the station. But at a small company like TechShot, um, everyone has an ability to have a close encounter, if you will, with astronauts, things that go in space, payloads coming back, going to launches is always great, of course. And there are companies. There's more than just TechShot involved in this industry. So there's another company. So we're in Metro Louisville, Kentucky here, just on the north side in Indiana. But in Lexington, Kentucky, there's another great company called Space Tango. They're a little younger company than we are, but boy, they've sure caught up quick. They do a lot of terrific work on board the station, and a lot of my good friends work there. And the company or this industry, the payloads world is really small. I mean, it's growing, but it's still fairly small. And I root for even our competitors in this space. Few of us who are doing this work overlap in all areas. We may overlap in some, but there's a little bit of differentiation among our offerings. And Space Tango's success can help build demand for TechShot products and services. It's that small of an industry, and I think we all take some pride in playing our part in growing the pie, making the pie bigger, so that we can all prosper. And again, just like at TechShot, folks at Space Tango are passionate and just doing this on purpose, if you will. So yeah, lots of new front doors popping up all the time in non-traditional areas like Kentucky, Indiana. It doesn't have to just be in Texas or Alabama or Florida or California for that matter. So yeah, I'm excited about it.
That's really cool to hear. Yeah, it's interesting how the interactions go between all the different contracting groups as well.
Right.
And really just trying to build up that pie, as you said, so everyone else, we all can prosper as a group. Now, one of the major interactions that TechShot has with the International Space Station that's relevant to 3D printing is that of the bioprinter. So
Right.
let's talk about it. What is the bioprinter? How did you guys get involved, and what's it doing?
So we have an in-house staff of scientists in addition to our engineers. And that is something that has set us apart for a long time. Although again, other people in this space are starting to add scientists as well. And our science staff came from a really strong regenerative medicine background. In fact, our chief scientist was the head of regenerative medicine at the Cardiovascular Innovation Institute at the University of Louisville before coming to TechShot. So within his ecosystem, within his set of contacts that he came from, he had a good relationship with a company that really is leading the way in I think they call it direct digital manufacturing, or essentially they make really high-end 3D printers of all sorts. These are not sort of desktop hobbyists. These are really the most capable that you would use for industrial applications and some research. And that company is called nScrypt. And they write their name with a lowercase n, capital SCRYPT, and they're in Orlando. And then our chief scientist, whose name is Gene Boland, has a relationship with another local company that had these custom formulations of bio inks, because printers need inks, and a bioprinter is no different. So you have to have a specialized bio inks that consists of different types of cells and nutrients, things like that go into a bio ink. So with these relationships, we started considering additions to our catalog, and another company that we know really well has gotten a lot of press, called Made in Space. They've been acquired by another company called Redwire more recently. And Made in Space had launched a 3D printer, plastics printer, to the station on the same mission that we launched, our SpaceX mission that we launched our first payload of the space station era versus the shuttle era, which was an X-ray machine from ICE. And so we saw that there's perhaps a project that we could tackle together with these great friends and leaders in their respective fields, and provide a solution that would be valuable to try out on board the station. And so that was in 2015 when we started having these discussions. By 2016, we had built a prototype. Again, our Techshot has a long history of working in the life sciences in space. So that's really versus, let's say, material science, which we're just now getting a little more into. But life sciences, cell culturing, tissue engineering, we've been doing tissue engineering in space for decades by this point. And this again also was sort of the next evolution of that tissue engineering focus for us. So 2016, we built a prototype and flew it on board the parabolic flight aircraft. And we had a team from mostly Techshot, but also this nScrypt company. There was an engineer from that company, and then an engineer or a scientist from the BioInk company called Bioofficial Organs. And they flew on board the privately operated Zero G Corp aircraft, which I think they call G-Force One, and which and most everybody else would call the Vomit Comet, right? And they went out and did 25 parabolas, so you got about 25 seconds of zero G, and they tested bioprinting a neonatal size heart ventricle, and did the printing with adult human stem cells. And it worked great. I mean, they tried different viscosities of bioinks, and tried printing different shapes and hollow tubes and all sorts of things, and it really worked well. And so then we set about to build one for the space station. Now, the reason why we really wanted to build and print and create tissue in space was partly due to this issue of organ shortage in the U.S. 22 people a day die on organ donor waiting lists. And we thought, well, this might be a solution perhaps to consider to help reverse that. So the reason you can't really bioprint on Earth effectively, because when you lay down the different layers that you need to build up for soft tissue, they just all sort of, the structure collapses, and whatever cells or whatever you want to put in that top layer just settles down to the bottom layer. So nothing stays where you put it.
Fascinating. Okay, that's what I was wondering of how.
Yeah, why do it in space? It's because it just collapses and settles out.
Okay.
And if you want to print on the ground and have your structure hold up against gravity, you have to add in what our chief scientist tells me are called cross-linkers. So you add in chemistry to add stiffness, but then that kills the cells. So you can have it look like something, but you can't have it function like what you want it, what it looks like.
Fascinating.
Print something that looks like a heart or a liver, but it won't function like one.
So if it's like, I guess in relation to say like an FDM style 3D printer, normally it's like a cool time or some sort of settling time for it to solidify. Is there in space, when it comes to bioprinting, some length of time that you need to be in zero G for it to stay formed?
So what a great question. And how our strategy for that is really not related to the bioprinter or the formulation. We have another payload. We have a huge catalog of equipment by this point, as you might imagine, and there are things up there right now, different devices. So this first test of the bioprinter we launched, besides the bioprinter, which is physically the largest device so far that we've ever built. We flew a payload that Techshot flew on the space shuttle. And actually, when Senator John Glenn went back into space at age 77, he operated this device for us in space. Wow. It's called the Advanced Space Experiment Processor, or ADSEP. And so just what Senator Glenn did is what astronauts did for us on some of our first test prints, which was an astronaut goes to this ADSEP box, which it's about the size of a consumer microwave oven. They drop a front door down, and then there are 3 other doors, smaller doors, and an astronaut will drop down one of those doors, take out a cassette about the size of a lunchbox. And then they take that cassette, which contains a bioreactor inside, and they take that over to the bioprinter. We've had them attach a see-through glove bag to the front, so we don't contaminate what's in the printer, and we don't get the bioinks in the printer out into the crew compartment. There's a zipper in the bottom of the glove bag. The astronaut puts the cassette in, closes the zipper, and then reaches in through the glove ports and places this cassette with the bioreactor in the bottom of the bioprinter. And then they go float off and do something else, and we take over from Indiana. Then we command the printer. We have cameras all inside. We control the temperature, humidity, lighting, everything from our office. And we have views inside our device that even NASA doesn't have access to. And so we command our printer to do a print. And once we tell the crew that we're done, they come back, put the lid on the bioreactor, and then put the lid on the cassette, the top of the cassette itself, float back over and insert it back into that ADSEP box, close it up, and again, we take over. And even though it might take, I don't know, moments to even hours on the high end to do the printing itself, you just can't bring that right back down to earth, because as you surmised, it would just flatten back out again when it got into gravity. So it has to be cultured and conditioned to toughen up over inside the bioreactor, inside ADSEP. Now that takes weeks. So far we've conditioned cells, because you don't print tissue, you print cells. You condition them into tissue, and that conditioning into tissue happens in the ADSEP locker. And we've conditioned and cultured a printed construct like 3 or 4 days. Brought it back. That was not enough. So we went for a couple of weeks, and that holds up pretty well. So we printed a human knee meniscus, and that came back. Everything looked great. Now, there are not a ton of soft cells or cells in a meniscus, so naturally it's going to hold up a little bit better. But even the parts that would normally just sort of collapse, they were great. So maybe 2 weeks is enough. We automate the change out of media in this device, and then the crew could come in and change it out after about a month. We could go months if we needed to, culturing a really thick, complex tissue. So they really have to work hand in hand. The printer, which has these sort of big syringes full of different types of cells, and it's a 4-head printer. And the print tips are really, really tiny, and you can swap out pumps and print tips and everything all on orbit. And so that's what we printed, those 2 sets of things so far. A heart construct in space made up of layers of muscle, nerves, vasculature, and some nutrients. And that one's going to take longer to should I say bake? I don't know. Our chief scientist talks about, when is a pancake a pancake? Is it when you pour the batter down into the pan? Well, no, that's batter. That's not a pancake. Once you've cooked it or conditioned it with heat and flipping it over and all that, that's when it's a pancake. Same thing here. Tissue isn't tissue until it's come out of ADSEP for X amount of time. And we're just now learning how much time it takes to do various tissues.
That's so fascinating. That's actually a great way of describing how it all works with the pancake. That's awesome.
Right.
So what do you see, just real quick, with where the future of the bioprinter is going to go?
So our own team is still interested and is still continuing to do work related to heart tissue, but we've opened it up for use by any team that wants to use it for anything. I mean, we do all the experiments, but if there's a team who's looking at liver, for example, and then actually there's a group called the Methuselah Foundation that I think has been funding some prizes that if you can create a thick liver tissue in any fashion, you do it in space, don't do it in space, they've got I think they've got some prize money for you. And so if there's a team that wants to look at liver, they can reach out to us and we can set up a space experiment. Now the payload is back from space. It was up there about 18 months. It's in our lab here now because we've learned a ton about making the tools on it easier to change out. So it was pretty easy before for the crew to manipulate, but we've made it even easier for the crew to swap out print tips and pumps. We're making it gentler on the cells that we print. So we're doing some change outs in some of print tips and things like that. So we're making improvements that'll be able to provide a faster, higher throughput. And it will launch again probably toward the end of next year. So we're really really doing a lot of work to just make it where it'll be on the station for years. We had to bring it back now because the first version of the SpaceX crew capsule or cargo capsule that we've been using to fly the bioprinter has a really big hatch, and so it easily fit through the door. Again, this is a huge payload, but the version of the Cargo Dragon that flies now is sort of a derivation of their Crew Dragon, which has a very small hatch or a smaller hatch, and so it would no longer fit in through that hatch. So now we brought it back on SpaceX 20, our SpaceX commercial resupply mission 20. And it'll launch back to the station on a Northrop Grumman cargo ship from Virginia called, the vehicle's called a Cygnus. And so that's got a big hatch. But then so SpaceX right now is the only vehicle that can bring anything back from the station. All other cargo ships burn up in the atmosphere. And until a new little mini space shuttle comes online called the Sierra Nevada Dream Chaser, we won't be bringing back the bioprinter, which we call the BFF, the Biofabrication Facility. So it's back here on Earth for a while, but we darn well know that we can't just bring it back later or easily when we want to. So we're just making all these changes right now.
Wow, so that's a lot to look forward to in the next year or so.
It really is.
That's awesome. So I believe Techshot is also working on a different kind of 3D printer, correct, for the International Space Station. Let's talk a little bit about that.
Yeah, so we're again with in collaboration with this nScrypt company from Orlando. We're working on what we call the Fab Lab or Fabrication Laboratory, and I said BFF was the biggest thing we built. This is essentially twice as big. So this will take up an entire space station rack, which is about the size of a large refrigerator you might have at home. It's pretty big.
Oh, wow.
Yeah, and so the chief goal of this one, whereas the bioprinter really looked back to Earth for purpose, right? I mean, it's trying to make off Earth for the Earth. It's trying to make life better for people here on Earth. We could take your own cells up, make you an organ, bring it back, no rejection drugs, et cetera. Again, that might be 15 years out, but we've started on the process. So the Fab Lab is more of something that will enable exploration. We're not really considering that we're going to make you something out of titanium in space and it's better than something you make out of titanium on Earth. I mean, there are really obviously some very mature technologies for 3D printing metal, powder bed, whatever, using lasers and things that are really reduced to practice well. But in space, you can't have a bed of powder just floating around in zero gravity. So this solution uses it's more bound metal deposition. It has a lot of similarities to like metal injection molding in terms of a paste that would have these microscopic flakes of whatever. So it could be metal, could be ceramic material. There are a lot of uses that NASA intends for this device. And again, we will own it and operate it, but NASA will be the major, at least the first customer. And this is just chiefly to enable exploration. If you are tens of millions of miles away from Earth, and the comms delay is 20 minutes alone each way, you really need to be more self-sufficient. You can't possibly think of all the spare parts you might need to bring, and if you could, obviously the weight of all those items would keep you from ever leaving the Earth. So the part of the solution is just to take some feedstock, and NASA's in-space manufacturing program has as a motto, make it, don't take it. And so that's what we're working on now is Fab Lab. It's a two-parter. One is a print module on the upper half, and the lower half is a furnace, and it would be the largest furnace ever flown in space as well. And Techshot, right now, even though we didn't build it, we manage NASA's 2 space station research furnaces. In fact, we're conducting research for a customer on board the station right now. And so how it works is you print you do your print of whatever complex part. We've seen some really complex geometries that we've been able to print. And then we call that the green part. It's really actually quite fragile. And then put it down below into the oven and raise the temperature up and essentially bake off the binding material. And you're left with somewhat porous, but not super porous brown part, as we call it then. Then you raise the temperature even further to like, well above 1,000 C, and then center it. So now you fuse together those particles in a solid piece. And if you want to do further finishing, you put it back up into the print module where there's a mill and a vacuum and a laser quality assurance scanner going the whole time as well. So we've been able to do all this whole process I described here in our lab perfectly. It works like gangbusters, and it makes really, really strong parts out of titanium. And then we're also going to start doing part of the challenge is electronic assemblies as well, which we did have a chance to try when we were on that Vomit Comet. We printed a cell phone antenna by swapping out the biological print heads.
Oh, wow.
And it worked. And so this device also will manufacture electronic assemblies, among other things.
That's super impressive. Yeah.
This one's a tall pole in the tent in terms of how long it's going to take to get to space, just because it's big, it's complicated. It's going to have a pretty specific slot that launch slot, because it'll take up the space of 8 normal adceps, if you will. It's 8 times the size of like our adcep locker. So that won't get to space until probably 2024, something like that.
Wow. So Techshot's working on the forefront of manufacturing space for space exploration. That's so cool, being able to print both organs or different bioprints, as well as the different tools that will be necessary going forward to really help push space exploration farther along. That's phenomenal.
Yeah, we're excited about. It just looks. It's the future we all kind of imagined. In some ways, you only have to look at a SpaceX Starship to think we're living in the future.
Wow. Yeah, that's true. Do you have any final parting thoughts for our listeners when it comes to either being a professional within 3D printing, or how to work within this space, or any final words of wisdom for our listeners?
Well, I don't want to be so cliche as to say follow your passion, but I mean it's true. If you, if you do your part, I mean, you have to get the educational background, and I mean, Elon Musk talks about, to him, degrees mean nothing to him, and I suppose that is becoming more and more true in some ways. I mean, 3D printing has become somewhat inexpensive. There are those, I mentioned that, Fab Lab and BFF are not desktop printers, but desktop printers do exist, and many hobbyists have them, and many people, young and not as young, have been able to do some amazing things at home with tools that they've got at home, and I think that passion and that skill set is more important than necessarily having an advanced degree in metallurgy or even mechanical engineering. And so as the industry grows, people just want the best people, right? We have an opening right now for an electrical engineer. If anybody has an inclination, we'd love to have first. Yeah, you heard it here first. So when we talk to our prospective prospective employees, we are really interested in what do they do at home, what are they doing on their own, what have they done on their own, what projects do they have. Most of our engineers have some home side project that is amazing. We hired a lot of engineers from a few years back from in Louisville, a group called Level 1 Makerspace, and so many communities now these days have a group of hackers, a group of people who are tinkerers, who get together and share tools and a space and come up with some really astonishing things. And that's the type of person that makes a great Techshot engineer. And I think it's probably true for Space Tango and others, that we want some people who are curious, engaged, hardworking, who want to see what they've been doing and extend what they've been doing on their home, on their garage benchtop to the highest plane, literally, right? Imagine being able to take your skill set in 3D printing and then say that you're going to build a 3D printer that goes to Mars. And 3D printing has been around, I say, a long time, but it's still in some fashion quite young. And there are experts, but it's not like it's so super mature that a younger person with a new approach is going to be dismissed. I think we're all eager to see new ways of doing things. What can you do with printers? We have a bunch of printers in our office now. So besides the ones we build, we buy a lot of them and use a lot of them and do a lot of things in house. And then we sort of, like any hot rod person, we find ways to make them faster, better. And so I don't know. I think if anybody has an interest in additive manufacturing, man, the world is your oyster, right? Beyond, I keep coming back to that, but just the joke makes itself. The universe is your oyster here. And I think it's only going to be more and more important for enabling space exploration into deep space.
Well, Rich, thank you so much for your time and for hopping on the podcast today to discuss with us everything that's happening at Techshot, the bioprinter, and the future of additive manufacturing. Once again, thank you so much for your time. And
terrific. It's a pleasure being with you.
Once again, we'd like to thank Rich for hopping on the podcast today to talk about 3D printing in space. If you'd like to know more about Rich or the work he's doing at Techshot, please check out our show notes. We have a short biography, some great photos he's provided us, along with a link to their website, which is techshot.com. Please visit their site. It's super cool and full of great information. They have stuff about their 3D bioprinter on there, along with all the other research projects they're working on currently. Thank you for tuning in to this week's episode of The Next Layer, a podcast for all things 3D printing. If you really enjoyed this episode, we ask that you please share it with all your friends, subscribe, and leave us a review. Thanks again, and we hope to see you at The Next Layer.